Welcome to Explore Engineering. In today's video, we will learn about the components of healthcare IoT and how they work together to improve the patient care. And we'll explore the sensors, communication networks, cloud computing, and data analytics in a simple and easy to understand way. So let's get started. First, we'll see what are the different components of the healthcare IoT. First is a sensor, which will sense the physiological parameter value from a patient's body. Then comes the wireless connectivity that will transmit data from the sensors to the LPU and LPU to the cloud or the server. Third is privacy and security, which will secure the sensitive health data. Then comes the analytics that will extract a meaningful inference from the data and apply them in an application. Next, you have cloud and fog. It is fog, it is not fog, FOG, fog computing that will store the data for short-term and long-term basis for future use. Then comes the interface that will provide an easy access to the application. So now we'll see these all components one by one in detail. First is a sensor or sensors. Here, the role of sensors is to form the first and most important layer of a healthcare Internet of Things system, and the sensors are responsible for collecting the physiological data from a patient's body and converting it into digital information that can be monitored and analyzed. So here you can see a patient is shown wearing different healthcare monitoring devices, including a chest sensor. Then he has a smartwatch and a portable health monitor. Okay. Now here these devices will continuously measure various health parameters and send the collected data to the connected healthcare systems. Okay, here through the internet, which is that is the data which is collected by these sensors or the devices. Now the wireless communication symbol here. This is the wireless communication symbol. Here it indicates that the sensor data is transmitted through a network for further processing and monitoring. Now here you can see examples of physiological sensors which are commonly used in the healthcare IoT. So you can see here an ECG sensor which will monitor the electrical activity of the heart. You have a SpO2 sensor which measures the blood oxygen levels, a temperature sensor, then which tracks the body temperature, a blood pressure sensor that monitors the blood pressure, a motion sensor that records the body movement and physical activity. So together these sensors will provide comprehensive information about a patient's health condition. Now here we can see that the sensors are the foundation of the healthcare IoT because they provide real-time health data, and this information helps the doctors monitor patients remotely, detect health issues early, and make informed medical decisions. So here we can see that how physiological sensors collect the important health parameter and serve as the primary data source in the healthcare IoT systems, enabling the continuous and efficient patient monitoring. Then comes second one, that is the wireless connectivity in the healthcare IoT. So here it shows how health data collected by wearable sensors is transmitted through the different communication technologies to the healthcare providers and the end users. Now here you can see a patient is wearing multiple physiological sensors such as ECG, SpO2, temperature, blood pressure, and motion sensors. So these sensors continuously collect the important health information from the patient's body, and the collected data is useful only when it can be transmitted to other parts of the healthcare system. So the wearable sensors, these will communicate with the local processing unit using a short range wireless technology such as Bluetooth and the Zigbee, and the LPU, it acts as a gateway that gathers and processes the sensor data. Then the LPU will send the information to a cloud server through the internet technologies such as Wi-Fi or LAN. Okay, here Wi-Fi and a LAN, and the cloud stores the information and manages the healthcare data, making it available for remote access and the analysis. So here you can see a healthcare professional, that is you are having the healthcare professional, then you have patient, and also like he's accessing the patient's data through the various devices, including the laptops, then desktops, smartphones, and the tablets, and then different communication technologies such as Wi-Fi, Ethernet. You have GSM, 4G, and 5G, which enable this access. Okay, and so here the wireless connectivity, it is a vital component of the healthcare IoT because it ensures seamless real-time transmission of the patient's data, enabling the continuous monitoring, faster medical decisions, and improved healthcare services. Then the third is privacy and the security. Here we can see the importance of the privacy and security in the healthcare Internet of Things system. Uh, we can see how sensitive patient health data travels through the multiple devices, okay, and networks before reaching the healthcare professionals, and why strong security measures are essential to protect this information. Now, here you can see again, a patient is wearing several healthcare sensors, including the ECG, SpO2, temperature, blood pressure, and the motion sensors. These wearable devices continuously collect the physiological data from the patient's body, and the collected data is then transmitted to a local processing unit through the wireless technologies such as Bluetooth and the Zigbee. Now, here you can see that the data moves through various networking devices. These are the networking devices, including the routers, then you have gateways and the communication towers before reaching the cloud servers. Now, these intermediate devices, these are known as network hops. Okay, these are called as what? Network hops. Now, since the data passes through multiple connected systems, each device becomes a potential target for cyber attacks. So, here, if any network device is compromised, then the hackers may gain the unauthorized access to the confidential patient's information. Now, here you can see that yeah, a hacker is attempting to intercept the healthcare data. Now, such attacks can lead to data theft, unauthorized access, then privacy violations, identity fraud, and legal consequences for healthcare organizations. Now, these threats make security a major concern in healthcare IoT environments. Now, you can see that the cloud server, it securely stores and manages the healthcare information, and doctors, then nurses, and the patients can access the data using the laptops, tablets, and the smartphone through the secure communication channels. So, here you have several security measures, like you have data encryption, authentication, and authorization. You have secure communication protocols, access control mechanisms, and the continuous monitoring. Encryption will protect the data both during the transmission and while stored in the cloud, ensuring that only authorized users can access it. So, the privacy and security are very critical components of the healthcare IoT. Strong protection mechanism help maintain the confidentiality, integrity, and availability of the healthcare data, ensuring the safe and reliable healthcare services for patients and medical professionals. Now, next is the analytics. So again, here analytics, it is responsible for transforming the raw healthcare data into the meaningful information that can be used by the doctors, nurses, and the patients for better healthcare management and the decision making. Now again, you can see here a patient is there. Here he is wearing various physiological sensors, and these devices will continuously collect the raw physiological data from the patient's body. However, the raw data is difficult to understand, and that cannot be directly support. It cannot directly support medical decisions. So the collected data, it is transmitted through a local processing unit or a gateway, and then stored securely in the cloud server. Now, once stored, the information is processed by the analytics engine here, which is shown. Now, this engine performs tasks such as the data processing, then it will do the data filtering, cleaning the pattern, and cleaning, pattern recognition, statistical analysis, and the machine learning. And these processes help convert large amount of raw health data into useful insights. Now, here you can see how different users receives the customized information based on their roles. So a doctor receives the detailed diagnostic report, then patient trends and the treatment recommendations, and here a nurse receives information related to patient monitoring, alerts and care updates, and the patient receives simplified health summaries, reminders and the personal wellness information. So this role based customization ensures that each user accesses only the information relevant to their needs. Uh, and here you can see how the analytics supports the disease diagnostic and decision making. So by analyzing the physiological data, the system can detect abnormalities such as irregular heartbeats, then high pressure, high blood pressure, or early signs of chronic diseases. Now, these insights assist the healthcare professionals in recommending further tests and treatments. So, the benefits include early disease detection, accurate diagnosis, then personalized treatment, efficient resource utilization, and the improved patient outcomes. So here you can see that analytics is a very important and critical component of the healthcare IoT because it transforms the raw sensor data into actionable medical knowledge, enabling the smarter healthcare decisions and better patient care. Then next you have cloud and fog computing. So here we can see that how uh, the cloud and fog computing will explain how large volumes of healthcare data generated by the wearable sensors are processed, stored, analyzed and made available to the healthcare professionals and the patients. Again, here we can see that a patient is there, he is equipped with multiple physiological sensors, and these sensors continuously monitor the patient's health and generate a large amount of heterogeneous data. Now, since the healthcare monitoring occurs continuously, the volume of data which is generated, it can become enormous over the time. So, the collected sensor data, it is first sent to the fog or the edge layer, which is represented by the LPU, that is the local processing unit or the gateway. The fog processes, that is the fog computing, it processes the data closer to the patient, reducing the amount of information that must be sent to the distant servers. Now, functions such as data filtering, aggregation and the real-time processing here, okay, are performed at this layer, and because processing occurs near the data source, fog computing reduces the communication delays, that is the latency, and it will provide faster responses during the emergencies. Now, after the preliminary processing, the data is transmitted to the cloud layer. The cloud provides a scalable storage where healthcare organizations can store massive amounts of patient information. And the cloud storage follows a pay-as-you-use model, making it flexible and cost effective. And the cloud not only stores the patient records but also supports advanced analytics, machine learning and artificial intelligence applications. So these technologies help to identify health trends, predict diseases and assist doctors in making accurate diagnosis. Now here you can see that different users access the stored healthcare information. So the doctors can view patient history, trends, alerts and the treatment recommendations. Then the nurses can monitor vital signs and receive notification about the patient condition. And the patients can access personal health summaries, activity reports, reminders and the lifestyle recommendation through the mobile devices. So here we can see the benefits of cloud and fog computing, which include the scalability on demand, then reliable storage, low latency with fog, cost effective and better decision making. So at the same time, it identifies the key challenges also, such as the data security, then it has a privacy protection and delays in accessing cloud stored information. So the cloud and the fog computing complement each other. That is, the fog computing handles the real-time processing near the patient, while the cloud computing provides long-term storage and powerful analytical capabilities. So here we can understand that how cloud and fog computing work together to manage the store, process and analyze the massive healthcare data efficiently, enabling faster medical decisions, continuous patient monitoring and improved healthcare outcomes. Then next comes the interface in healthcare. So here the interface, it is a point where the users interact with the healthcare data and the services. Since the healthcare information, it is very critical and sensitive, the interface must present information clearly, accurately, and in user-friendly manner. Now, here again you can see that the patient is equipped with some wearable sensors which are attached to the body, which collect continuously physiological data such as heart rate, oxygen, temperature, blood pressure, and physical activity. Then these sensors generate the health data, and that is transmitted through a gateway or the local processing unit here. Okay, and the data is then sent to the cloud servers, where it is stored, analyzed, and processed using the analytics and artificial intelligence techniques. Now here you can see a healthcare IoT dashboard which represents the user interface. Okay, and the dashboard organizes the complex healthcare data into easy to understand formats such as charts. Okay, you have such as here you have charts, then you have graphs, numbers, and alerts, and important patient information including the heart rate, blood pressure. Okay, here heart rate, then you have blood pressure, then oxygen level, body temperature, activity records, then you have health trend. These all are displayed here in a structured manner, and this helps users quickly understand the patient's health status without analyzing the raw sensor data. So this interface, it is accessible through multiple devices such as laptop, then desktops, tablets, and the smartphones. And this will allow the healthcare professionals and patients to access information anytime and from anywhere. So the real-time notifications and alerts can also be displayed when abnormal health conditions are detected. Here you can also see that how different users will receive the customized views based on their roles. Here a doctor can access detailed patient history, laboratory reports, diagnostic information, and the treatment plans. Then a nurse receives information related to vital signs, monitoring, then alerts, medication reminders, and the patient care updates. Then a patient sees simplified information such as health summaries, activity reports, appointment reminders, and the lifestyle recommendations. So this role-based access, it ensures that users receive only the information relevant to their responsibilities. And here we can see some key interface features like including clear visualization, real-time updates, easy navigation, data privacy controls, and quick access to healthcare services. So these features improve the usability and help users make informed decisions efficiently. Even you can see here some benefits also, that is the you have like a quick understanding of patient status, timely decisions and interventions, improved patient care and safety, then better communication, higher satisfaction for all the users. So here the interface, it is a crucial component of the healthcare IoT because it transforms complex healthcare data into what? Into a meaningful, understandable, and actionable information, enabling better healthcare management and improved patient outcomes. So this was about the components of the healthcare IoT. I hope you all have enjoyed the video. Please don't forget to subscribe, share, and like. Thank you.